Hello, grade 8s. Today's math video is going to be on 1.5, the Pythagorean Theorem. Let's get started. So right here, I have a triangle, right? Three sides. But this is a specific triangle. It's a specific name. Down here, where these two legs meet, A and B, they form a 90-degree angle, or a right angle. Anytime you have a right angle and a triangle, we refer to the triangle as a right triangle. So today, Pythagorean's theorem is just going to deal with right triangles. And there's some really cool things we can do with right triangles. And we're gonna show you that today. So we're just going to kind of go through it. And before I tell you what Pythagorean's theorem is, we're just going to see if you can kind of discover it on your own. So let's get started. Here's my first example. So here is a right triangle, and I have given you the lengths of each side. In this case, side A is 3, B is 4, C is 5. Now, check this out. I want to show you something cool that we can do here. I am going to draw a square, or attempt to. It's not going to be perfect, but that's okay. I'm going to try and draw a square off of each of the sides of my right triangle. I want to show you something cool that we can discover off of this. So watch this. And this is what Pythagorean discovered as he was playing around with these. Okay, help me out here, grade 8s. What would the area of this square be? I know what it is because I know the side length here. If a side length of a square is 4, I know the area is 4 times 4. So in this case, the area right here is 16. The area of this square off of A would be 3 by 3, which would be 9. And the area of the square off of this longest side, which we call the hypotenuse, but we'll get back to that later, 5 times 5 is 25. I want to see if you can see a pattern develop or emerge. Check this out. 9, 16, 25. Well, you know what I see right here? I can go and play around with these numbers. They're friendly numbers. 9 plus 16 is equal to 25. Huh. So I just found out that the square of A, square of B, when you add them up, is equal to the square on C. Maybe that was a fluke. Who knows? Let's go to another example. Here's another example. So same thing. Let's draw our squares. I'm just going to do it really quick here. It's going to look more like a rectangle. I apologize, but you got to use your imagination a bit, as Mr. Norman here tries to do his best. Okay. Well, what would the area of this square be here? Well, the side length of this square is 8, so I know 8 times 8 is 64. And over here, the side length is 6. I know 6 times 6 is 36. And over here, I know the square would be 10 times 10, so that is 100. All right. Well, what I noticed in this example previous was that the square of A and the square of B, when I added them together, gave me the square of C. Let's see if this works here. The square of A is 64 plus the square of B, which is 36. 36 plus 64 is equal to 100. And in this case, guess what? It works out again. And that's what Pythagorean discovered. He realized that the square of the one leg added to the square of another leg is equal to the square of the longest side, the hypotenuse. So let's take a look at another example here. Anybody want to guess what the area of the square would be for C? They don't give you a side length here. We don't have side lengths anywhere. How is this possible? Well, remember, in the previous two examples, we discovered that when we added the square of the one leg and the square of the other leg, added them together, it gave us the area of the longest leg, the hypotenuse. Same thing here. So let's go here then. That means we should be able to add 25 to 9, and that will give us the area of C. 25 plus 9 is 36. Take a look at these numbers here for a second. What do you notice about 25, 9, 36? What do they all have in common from previous lessons? These numbers are all examples of perfect squares. So if I wanted to know what is the length of A here, well, I would just go like this. What's the square root of 25? Oh, I know, that's 5. What if I want to know the length of B here? Area is 9. I know the square root of 9 is 3. And I just figured out that this is 36, and the square root of 36 is 6. So I just figured out the side lengths of my right triangle by using Pythagorean's theorem. Let's try this one more time. Here you go. Here's a triangle. One side length, 5. Other side length, 12. Can you help me figure out what the side length of C is? Well, first things first, let's draw our square. Pause your video right now and see if you can do the answer on your own, and then hit play and see if you get the answer that I come up with. Okay. Alright, so there's my 3 squares. So what is the area of this square? Well, the side length's 5, so I know that the area will be 5 times 5, which is 25. Over here, side length's 12. 12 times 12 I know is 144. So what I've learned is the square of the one leg added to the square of the other leg gives me the area of the length of the longest side. So 144 plus 125 is 169. And we've learned in previous lessons that the square root of 169 is 13. That's Pythagorean's theorem. Being able to take the 2 side lengths and figure out what the third side length is. Alright, so once again, I want to go back to this first one. The 2 shortest sides of a right triangle are what we call the legs. Okay, so A and B in this case are the legs. And the longest side is going to be called the hypotenuse. Okay, I'm going to try my best to spell this word here. It's going to take my whole 10 minutes just to spell this word. Hypotenuse. That's not bad. I'm pretty proud of my ability there to spell it. So another way to think about it, the hypotenuse is always the side opposite the right angle. So here's your question I'm going to leave you with. Try and answer it. Comment on Edmodo. Here you go. You have a right triangle. One side length is 5. One side length is 7. Can you tell me what the length of C is? Hint, hint, it is not a perfect square. Okay? Do your best. Comment on Edmodo. We will work on this tomorrow in class. Thanks for listening. I will see you guys tomorrow in class. Have a great night.